Welcome back to Wickerson Studios. My name is Michael Wickerson, and I am continuing with single variable calculus with a sole goal in my mind. And for anybody that's been watching my series, I recently did a series, I don't know, a couple of weeks back on the one-liners for Python dealing with machine learning using the ghpython remote node. Well, I want to drive some of that machine learning one-line Python nodes by functions. And I actually believe that functions are probably the most beautiful occurrence of geometries that you may want to rotate or revolve around certain axes to produce beautiful forms. And I think somewhere in here, for anybody that wants to reach out to me and have a real conversation about this, I think plugging in a series of inputs for the outputs in beautiful functions like the ones I have here that are fully parametric into those nodes is going to be extremely exciting and new for me. If not, I haven't seen other people doing it in this form of 3D modeling. And I'm still staying to a 2D model to keep my head on it straight. And whereas I feel like I'm just doing the basics to this stuff, sometimes I take a step back and say, what is really going on here? Like, what are the possibilities here? Anyway, I've written the first exercise of the first 20 of this series dealing with single variable calculus, but I moved on to functions. And I always start with something pretty simple, and that's a really nice scribble tool that outlines what's happening here. And I'm starting to become more proficient, obviously, in writing out a few things. You can see how slow the script is as I'm moving it around. Nothing's beyond 2D, but you see it's still tricky to grab hold and move it around. Lots of information about functions and what you might want to do and how you start thinking of those as domains and ranges. The domain convention is something that we're going to play with in certain domains. Otherwise, we're going to assume we're going to the real numbers extenuating in both areas of the axis. The axis is something that I built, and I use that as a script right here constantly, and that's the first script that I'll probably make into a plugin. And then I've just illustrated a very simple graph here, which I'll just make present by just highlighting it. You see I have a very simple graph that if I took that along with our axis graph, you can see I have a parametric model that I can go in and play with the domain, and I'm using an y equals x squared function. Not that it really matters. That's just what I'm plugging into the expression. And that's basically what's going on as you play with different ranges. And I actually have an amplification, and I can shift that in different areas by moving that grid up and down. So I have really nice control of my functions and a labeling system that works very well for it. And I can play off of that and slide them around. And what I've done is done just a nice, I don't even remember which plugin this comes from. Let's just check that out, Control-Alt. Of course, it defaults and goes right over top of it, so I can't see what's happening. It's pointing. There we go. It's a tool coming out of pufferfish, which is nice. And you could just do. Actually, I just have to pull it in one direction, but I think I pulled it in two. Actually, I think both sides is off, so I could just be using. I think it might be nice to just throw in this Boolean right now, just for fun. Boolean toggle. Let's throw that in there, both sides, and put it to true. And not really something I need, but I was wondering, there's no point using the pufferfish plugin if you're not going to really use it. There it is, pushing the line to both sides. I'm just going to use it in that instance. So that's my template. And then I went on to write in node scripting in Grasshopper that tool as well, using that one pufferfish plugin. If it doesn't work for you, you can just use offset curve, which comes with vanilla Grasshopper. This one I've gone in, and I've got my amplifications. I played with my my domain, a range on that to how big I want that ellipse. Pretty simple stuff to start graphing, but to understand what's going on. If you're going to define your domain, you technically should use another function that's different from f and name it. And I've made my subtle changes in here that I've applied my domain from 1 to -2. So let's just jump out of that one, jump into this one, and there it is. Keeping in mind that we're actually shift control still showing this whole axis. And there's our data driving through. Pretty interestingly enough, our sliders, depending on the domain we want to go. Actually, we're not even using those numbers. We're actually presetting our domain. You can see how it's set here and hard coded in. And I've made my changes in red, so I think I'll just take them off. And probably the best thing to do would be, for simplicity, for showing sake, take these to disable, take these to disable. And there we go. Now we're going to be able to see everything that I want to show you. Nice little parametric model. What I did here was I pulled in the changes that have to occur if you want to categorize things correctly and slide things around correctly. And the other thing I added was a circle open at this end because it was less than 2, not including 2. And then I put a surface on this area because it was greater than or equal to -1. So a little bit of red finesse going into there as I work. Let's take this one off. And you get kind of tired doing node scripting after a while. You start to think, well, this is a lot of work just to basically could be doing something simpler. Here's a script that's just going to default to the absolute value of x. And what's nice here is the one thing I had to do and shift differently is I had to take my interpolated curves and reduce the degree to 1. Otherwise, I was getting this very strange. I'll show you. If I disconnect this, it's defaulted to a 3 curve, and if I disconnect that 1, you'll see that it kind of behaves like a nerve curve degree 3, and that's not actually the graph. So you have to watch for things like that. And little subtle changes, little renaming of the script, just y at k, x. So I've called the functions different at each one, and then you can also slide around and change where you want to label that or find any point on that line at any point. Which is nice. They're all fully parametric scripts. And all you really have to do is just change the thing that you're working on. Now, this one was very interesting, which is where it went. And I started to get bored of just using Grasshopper script. And I wanted to show off a little more proficiency in other areas, including Python and C# programming. And here's a nice example of 1 divided by x minus 1. And you get this asymptote that nothing crosses the 0 line because you cannot divide, x at 1, because you cannot divide, 1 minus 1. You can't divide by that, it's 0. So there's no way it's going to reach out into that area. So as I went into here and I started to script it differently, I found a way to bring my domain in, plug in my script, I divided it, and I actually used a little logic, which as soon as I start using logic like this in Grasshopper, like if it's greater than this, not what is larger than, I'm going to call the list. I'm going to take it out of there and I'm going to generate this curve. So those are the ones that are greater than x at 1. And then I also have, and I've set the value of 1 at the second number 1. And then these are the ones that are less than number 1. And I'm able to draw these lines like this and keeping my x and y grid. The only thing I didn't like was y went in this direction. So I did a quick mirror off of the xy plane. And I'm able to label all of that correctly. Change the labels a little bit. So you start to do a little logic in here. And as soon as I start doing that, I'm like, well, the nodes are getting a little spaghetti-like in Grasshopper. I don't know if I want to do that. So what I did was I said, well, I probably have something in ghpython and C# that will work similar to this. So that's exactly what I did. I took these and let's put enable. And here they are. As I select them, you'll see what's selected. They both do the same thing. The one problem with not building a little extra logic, which I wrote into Python, I like writing and testing my scripts and my logic in Python and then putting it into C afterwards, because C is a little more type sensitive. It's harder. I don't know. It's what's it called? It's more, well, it's just difficult. You can't miss anything. You can't assume it's going to do anything for you, but it's easy to debug. So sometimes I look back and forth at these scripts. So I had a nice little script that I could just customize and switch over to taking number lists and producing points from those number lists. And that's exactly what I did. I took the range of x. It's going to process y. And the function I'm going to put in there, I actually didn't end up using this. I just hard-coded in the function into the script. It's a very simple script. You're going to list a double set of numbers, make a new list, which is a double, and for each double value, because you're labeling value as a double, in numList, and you have to think that's a float in Python, you're going to basically add that number. You're going to add that function to that. So you're going to take 1 divided by value minus x, minus 1, which is basically going to solve exactly what's being solved in the expression node. Now that works, but when you start to interpolate those points, it's going to run down through the middle and do this weird funky line like this. It's going to try and go zing zing and join at the top and the bottom by your domain and range limits. And that's not what you want. You just want 2 curves. So what I did was I took that off, disable, and I don't need this one on anymore because that one's disabled. And so this whole script in Python, which does the trick with all that logic, literally it's this first part building the range, and then this is all I had to do to produce the outcome without the labels. I mean, it's actually falling pretty much in the center without the labels. You still have to go on and do a bunch of little funky work to here. But these little 5 nodes are a lot simpler than this big mess of stuff, because the Python script writing in here is actually one that makes a lot of sense to me. And I wrote it myself, and I kind of generated it away from the C script that was working. Mind you, it didn't have the the value over or under. So to learn Python, I think it really is taking your node scripting in Grasshopper if you haven't done it. So I produced a bunch of blank lists, number 1, numList, x, numbers 2, numList y, and I said for value x in numList. If value x is greater than 1, then do this. And I actually distinguished my val1 from my val2s. Val x from val y, and I know it can be written better if I have to write multiple script that looks almost similar, but I don't mind it because it generates these the data that falls out of here very nicely. No errors in the program. I end up with these lists exactly where I want them to be, and you'll see I end up with these points over on this side, these points over on this side, and then I can draw a list between them, and they don't join between. So I've separated that data. So that's a lot of information as I go into here and do functions. And I'm going to plug through a ton of functions. And periodically, one of the next ones I'm going to use is the square root of the square and the signum function. And I might put those into Python Node because I'm thinking about what I want to make into a plugin for the Mathy that wants to handle absolutely beautiful curves. And that's what this whole program is about and why I'm doing this. It's for the person that wants to really gain control. I mean, I have to select all these. Really gain control of their data in a parametric way as they slide through and have some fun and change things. I think I can just play with the A value here. Oh, not plugged in. Let's plug that into there and see what we can end up doing. 0.7. There we go. I picked the most boring function to do it on and had the lowest value. So that wasn't exciting without the exponential. I chose the one linear one. That was just the absolute value pushing the negative slope up in this direction so there'd be no negative. So you start to understand what's happening. And once again, you're giving yourself a ton of wonderful curves. And as you get in here and start to say, okay, where am I going to loft? Where am I going to move these? What am I going to build? For those that draw 2D and then think 3D, this is the tool to really get you understanding what's happening. So I'm just going to keep plugging through. You can get these files. I think they're worth $3 on my GitHub for the next month off my Patreon tier 1. So thanks very much for watching. Michael Wickerson at Wickerson Studios.